Hi dears, this is Ethiopedia by Desu Birchit. In this section, we will discuss graphs of relation. Let's start with the definition. The graph of a relation R is a set of all points x, y in a coordinate plane such that x is related to y through a relation R. Let's illustrate on this definition by using examples. The first example is draw a graph of a relation y equal to x plus 1. This is linear equation because the power of each of x and y is 1. It's simple to draw the graph of linear equations because what is expected from us is just to find any two order pairs that satisfy the equation and then draw a straight line that passes through these order pairs or that connects these two order pairs. But to make it clear for you, let's follow a step-by-step approach. The first step is to draw x-axis and y-axis. X-axis is a left-right arrow or an arrow that extends to the right and to the left, and y-axis is an up and down arrow or the arrow that extends to up and down. The point of intersection of x-axis and y-axis is the origin. The arrow to the right of the origin is the positive x-axis. We can mark points at equal interval on this axis. These marks represent numbers like 1 up to 5 or any other positive numbers with equal interval between consecutive numbers. Those to the left of the origin are negative numbers. Again, we have to make mark at this side of the x-axis. Arrow above the origin represents the positive y-axis and below the origin represents the negative y-axis. We have to divide these axes to equal intervals as well. Step 2, find any two order pairs that satisfy the relation. For the sake of operational simplicity, it's recommended to use the two intercepts, that's x-intercept and y-intercept, as the two order pairs. X-intercept is the point where the graph crosses the x-axis, or it's the point where y value equal to 0, and y-intercept is the point where the graph crosses the y-axis, or the point where x value equal to 0. Operational simplicity lies on the fact that since either of these two variables is 0 as the intercept, we can easily solve the other variable. When x equal to 0, y equal to 0 plus 1, which is equal to 1. So 0, 1 is the y-intercept. When y equal to 0, 0 equal to x plus 1. This implies x equal to negative 1. So negative 1, 0 is the x-intercept. Let's indicate the order pairs on the graph. In the order pair 0, 1, 0 is the value of x. X is 0 on the y-axis. 1 is the value of y. Positive 1 means one digit above the origin. So 0, 1 is the first mark on the positive side of the y-axis. When we come to negative 1, 0, negative 1 is the value of x. That's located 1 unit to the left of the origin. And 0 is the value of y. At any point on the x-axis, the value of y is 0. So negative 1, 0 is 1 unit to the left of the origin. Step 3, draw the graph by joining the 2 points or by drawing a line that passes through these 2 points. The line looks like this. This straight line represents not only these two order pairs, but also any other order pairs that satisfy the equation y equal to x plus 1. So we can name this straight line as y equal to x plus 1. The graph extends indefinitely to the entire portions of x-axis and y-axis. Therefore, domain of relation equal to all real numbers and range of relation equal to all real numbers. We can use a vertical line test to check whether this relation represents a function or not. A vertical line test states that if a vertical line touches the graph only at one point, that graph of relation represents a function. If the vertical line touches at two or more points of the graph of a given relation, that relation is not a function. If we draw a vertical line at any point on this graph, that vertical line touches the graph of y equal to x plus 1 only at one point, Therefore, this relation represents a function, or this relation is a function. The graph, what we drew is the graph of equation, meaning x and y in the relation is related by equality sign. We can also draw the graph of inequalities. Inequalities are those signs like less than, greater than, less than or equal to, and greater than or equal to. As an example, let's draw the graph of these inequalities. Draw the graph of the relation y greater than or equal to x minus 2 and y less than negative x plus 4. Again, let's follow a step-by-step approach to draw the graph of these two inequalities. The first step is just to draw x-axis and y-axis. X-axis is this left to right arrow, and y-axis is this up and down arrow. Then let's divide both x-axis and y-axis to equal intervals. Step 2. Find any 2 points for each of y equal to x minus 2 and y equal to minus x plus 4. To form these equations, what we did is just we replace greater than or equal to sign in the first equation by equality sign and less than sign in the second equation by equality sign. As I discussed above, it's preferable to use the intercepts to find these two order pairs. When x equal to 0, y equal to 0 minus 2, which is equal to negative 2. So 0 comma negative 2 is y-intercept of this equation. When y equal to 0, 0 equal to x minus 2. This implies x equal to 0 plus 2, which gives us 2, meaning 2 comma 0 is the x-intercept of the equation y equal to x minus 2. When we move to the second equation, that is y equal to minus x plus 4. When x equal to 0, y equal to 0 plus 4, which gives us 4. So 0 comma 4 is the y-intercept of this equation. When y equal to 0, 0 equal to negative x plus 4. This implies x equal to 4. 4 comma 0 is the x-intercept of this equation. We can locate each of these four order pairs or each of these x-intercept and y-intercept on the xy plane we drew. 0 comma negative 2 means 2 units below the origin. 2 comma 0 means 2 units to the right of the origin. 0 comma 4 means 4 units above the origin. And 4 comma 0 means 4 units to the right of the origin. Step 3. Draw the graphs by joining the 2 points of each equation. At this point, we have to refer back the original inequalities in order to decide whether the solid line or broken line should we use to draw the straight line joining these 2 points. We have to use broken line for less than or greater than sign. We use such lines just to show that the order pairs on that line are not part of the graph. We use solid line for less than or equal to or greater than or equal to signs. By using such solid line, we convey a message that the order pair on that line are part of the graph. The first inequality is greater than or equal to. So we have to draw a solid line that passes through the intercepts 0 comma negative 2 and 2 comma 0. These are the intercepts of the first equation. The name of this straight line is y equal to x minus 2. The second inequality is less than. The intercepts we found out for this inequality are 0 comma 4 and 4 comma 0. We have to draw a broken line passes through these two intercepts and name this broken line as y equal to negative x plus 4. After having this, we can proceed to step 4. Step 4 is to shade the region which satisfies both inequalities. Until now, we didn't indicate the order pairs that satisfies greater than or equal to or less than signs. The solid line we drew indicates order pairs that satisfies the equation y equal to x minus 2, because if we take any order pair on that line, it satisfies the equation. The broken line indicates the margin or border of the order pairs that satisfies the inequality y less than negative x plus 4. These two lines divide the graph into 4 different regions. We can designate the region to the right of both lines as region 1, the region above both lines as region 2, The region to the left of the lines as region 3 and the region below the lines as region 4. Don't confuse these designations with the quadrants of XY plane. These designations indicate the regions bounded by these two lines, that's the solid line and the broken line. The order pairs that satisfy both of these inequalities lie on one of these four regions. To figure out that region, we have to take one order pair from each region and check with the inequalities. To check those order pairs, we have to determine the point of intersection of these two lines. The solid line is y equal to x minus 2 and the broken line is y equal to negative x plus 4. The coefficient of x in these two equations are equal in magnitude but opposite in signs. So if we add these two equations, we can eliminate x and solve for y. That's y plus y is 2y. X plus negative x is 0. No need to include 0 in the addition. Negative 2 plus 4 is 2. 2y equal to 2 means y equal to 1. We can take either of the two equations and substitute 1 in place of y to solve for x. Let's take the first equation, that's y equal to x minus 2. Substituting 1 in place of y gives us 1 equal to x minus 2. We can add 2 in both sides of the equality. 1 plus 2 is 3 equal to x minus 2 plus 2 is simply x. The point of intersection of the two lines is x is 3 and y is 1. So the point of intersection is 3, 1. The origin or 0, 0 is to the left of this point of intersection. So let's take this order pair with each inequalities. The first inequality is y greater than or equal to x minus 2. This implies 0 greater than or equal to 0 minus 2, which implies 0 greater than or equal to 0 minus 2 is negative 2. 0 greater than negative 2 is always true. The second inequality is y less than negative x plus 4. This implies substituting 0 in place of y gives us 0 less than substituting 0 in place of x gives us 0 plus 4. This implies 0 less than 0 plus 4 is 4, which is again true. Since both inequalities are true at 0, 0, the region we designate as region 3 is the region containing all order pairs that satisfy both inequalities. We have to show this region by shading or drawing boxes like this. If 0, 0 failed to satisfy either or both of these inequalities, we would have to proceed to check an order pair in the other regions until we find the ones that satisfy both inequalities. We can find the domain and range of this relation. The shaded region is the region to the left of number 3. That means number 3 is the maximum x value, but it's not part of the graph because an order pair 3, 1 and other order pairs on the broken line do not satisfy the inequality y less than negative x plus 4. Hence, domain is the one that satisfies both inequalities. So domain of relation equal to x such that x less than positive 3, or it can be expressed as negative infinity, 3 in parentheses. Range of relation equal to the shaded region extends to the top and bottom indefinitely, meaning all y values are included in this region. Therefore, range of relation is a set of all real numbers. This relation is not function because if we draw a vertical line on the shaded region, it touches the graph at more than one point. By this, I wrap up part 3. If you have any question or suggestion, jot down on the comment section. Thank you for your attention. Goodbye and stay safe.